This is survey. So today our topic is metrics. So in metrics, what are the evaluation metrics in machine learning? So evaluation metrics are measured to assess the performance of a machine learning model. This helps you to understand how bad your model is at making predictions. So there is one example. Imagine a student writing an exam. This evaluation matrix is their score, a way to judge their performance. Similarly, in ML, we score our models using metrics. So, why are the metrics important? So, metrics they help you to compare models to one model to another model, and they know the predictions values, accuracy, etc. And they highlight errors your model is making. And another one is helping tune your model to avoid overfitting and underfitting. And so if your model is good enough for real development environment. And types of matrices, here two types of matrices: classification matrices and regression matrix. So classification matrix, so in classification matrix we have six types: and conflicts matrix, accuracy, precision, recall, f1, rvc curve, and auc. So first we see conflicts matrix. So definition: a table show actual values versus predicted values. So in confusion matrix, there are four components. TP means true positive, TN means true negative, FP means false positive, FN means false negative. So example, confusion matrix help you to see not just how many were right, but how the model made mistakes. So second one, accuracy. So proportion of correctly classified samples out of samples. So here's the formula: accuracy is equal to TP plus TN by TP plus TN plus FP plus FN. So when we to use, works when works well when all classes are balanced. When not to use, mislead with imbalanced data sets. Example, if we have 100 samples and the model correct prediction is 90, accuracy is 90%. Next one is third one, precision. Definition: out of all predicted positives, how many are actual positives? Formula: precision equal to TP by TP plus FP. So when to use, important when false positives are costly. Examples: spam detections like emails, anything, etc. Recall. So out of all positive actual positives, how many did the model fit? So formula is equal to TP by TP plus Fn. When to use, important when false negative are costly. Example, cancer detection, F1 score. Fifth one, F1 score, harmonic mean of precision and recoil. Formulas: F1 equal to 2 into precision into recoil by precision plus recoil. When to use, good balanced when the both precision and recoil matter. Example, think of F1 score as single metric that balances the trade-off between finding positive and being right about them. RVC curve and ACU, lost and final. So RVC curve plots TPR versus FPR at various thresholds. So AUC means area under curve. So summary of the model performance. One means perfect, 0 point means random guess. Example, the higher the ACU, the better model is separating classes. And here classification matrix code. So here I load the data sets and convert in y value, converting into binary classifications, and I train and test the values, and I use the logistic regression model, and I fit the x train values, y train values, and predicted the y predicted values and probability values. Next I print accuracy, precision, recoil, f1. So in confusion matrix I will print it and RVC curve, and I will plot means bar graph I will show this all data in the bar graph. So the output is, so here the output of the code is accuracy is 1, presence is 1, recoil 1, F1 score 1, and it is the conflict matrix in bar graph. And this is predicted values and actual values. ROC curve. So it is true positive rating, false positive rate. And another matrix is regression matrix. Here four types of regression matrix. So first one is mean absolute error definition, average of absolute difference between rated and actual values. Here formula is 1 by n sigma phi equal to 1 to n and mod of yi minus y cap I. And interpretation, on average our model is the far off. Example, if MA is 10, then predictions are the 10 units and average. Second one is mean square error definition, average of the square difference, and formula is here. And here only difference in the formula is square because mean square error. And third one is root mean square error definition, uh, square root of means. Here we apply only square root to this mean square error, and it is the same units as the output. Example like MAE, but gives more weight to the bigger error. And last one is R square. So coefficient of determination represent proportion of variance explained by this model. Formula is here. And range minus infinity to comma 1. 1 means perfect fit, 0 means basic line, 0 less than or 0 worse than mean. Example, r square of 0.8 means 80% of variance. Output is explained by the model. So here code, regression matrix code. So we input numpy, Python libraries. Now we can input. Then we load the data sets and train and split, and we use the model linear regression, and we find the MAE, MSE, RMSE, R square, and print the here values, and we will print the scalar plot of actual values versus predicted values. So here output, I will run it again. So output is mean absolute error is 42.79, MSE 2900.19, root mean square error 53.85, R square error. So R square is 0.45, and scale plot actual values versus predicted values. So it is the actual values and predicted values. This is the topic of evolution matrix. Thank you.